Today, we're diving into the fascinating world of plastic injection molding, a process that's behind so many of the things we use every single day. From the case on your smartphone to the dashboard in your car to your favorite Lego bricks, this process is everywhere. Stick around as we break down exactly how it works, explore its many uses, and explain why it's such a big deal in the modern world. Plastic injection molding is a way to take tiny plastic pellets and turn them into precise, durable, and sometimes incredibly intricate shapes. It's fast, it's efficient, and it's been a game changer for industries around the globe. But how does it actually happen? Let's take a deep dive into the process, step by step. First things first, let's meet the star of the show, the injection molding machine. This beast is made up of a few key components: the hopper, the barrel, the screw, the mold, and the clamping unit. Each one plays a critical role in turning raw plastic into a finished product. Here's how it all goes down. Step 1. Raw material. Plastic starts as small pellets, tiny beads of polymer, like polyethylene, polypropylene, or ABS. These pellets are dumped into the hopper, which is basically a funnel that feeds them into the machine. Think of it like loading coffee beans into a grinder, except instead of a latte, we're brewing plastic parts. From the hopper, the pellets slide into the barrel, a long heated chamber where the magic starts. Inside the barrel is a giant screw that spins and pushes the pellets forward. As it turns, the barrel's heating elements, sometimes cranking up to 500 degrees Fahrenheit or more, melt those pellets into a gooey, molten plastic soup. The screw doesn't just mix it, it also builds pressure, getting that molten plastic ready for the next big moment. Step 2. Injection. Once the plastic is melted and pressurized, the screw acts like a plunger and shoots it super fast into the mold. The mold is the heart of this operation. It's a custom-made, precision-engineered metal cavity that's the exact shape of the final product. We're talking tolerances as tight as 1/1000th of an inch here. The plastic fills every nook and cranny of that mold in a fraction of a second, thanks to pressures that can hit tens of thousands of psi. But before the plastic can even get in there, the mold has to be locked tight. That's where the clamping unit comes in. It slams the two halves of the mold together with enough force to withstand that insane injection pressure, sometimes hundreds of tons of force. Once the plastic's inside, it's held there under pressure for a few seconds to make sure it packs in perfectly. Step 3. Cooling. The mold isn't just a passive shell, it's got channels running through it where coolant, usually water, flows to suck out the heat. This solidifies the plastic into its final shape. Cooling time depends on the part. Thin pieces might take just a couple of seconds, while thick, chunky ones could need a minute or more. Timing's critical here. Too fast, and you get defects. Too slow, and you're wasting time. Finally, step 4. Ejection. Once the plastic's cooled and hardened, the clamping unit releases, the mold splits open, and tiny ejector pins pop the part out. And just like that, you've got a finished piece. The machine resets, the mold closes, and the cycle starts all over again, sometimes churning out thousands of parts an hour. Now, that might sound simple: melt, inject, cool, eject, but the precision and engineering behind it are mind-blowing. Every temperature, every pressure, every second is dialed in to perfection. And that's what makes this process so powerful. But what exactly are we making with it? Let's talk about that next. Plastic injection molding is the unsung hero behind so much of our daily lives. Seriously, take a second to look around. Your phone, your car, even the chair you're sitting on might owe a little something to this process. It's everywhere, and it's versatile enough to serve industries you might not even think of right away. Let's break down some of its biggest, most mind-blowing uses. First up, the automotive world. Cars are packed with injection-molded parts. Think dashboards, door panels, air vents, and even those tough-as-nails bumpers. These pieces need to be lightweight to boost fuel efficiency, strong enough to handle crashes, and cheap enough to keep car prices reasonable. Injection molding nails all three. Plus, it can churn out parts with wild shapes, like the curves of a grill or the clips that hold your wiring in place. Fun fact, A single car can have over 10,000 plastic components, and most of those come straight from an injection mold. Next, let's talk toys, because who doesn't love a good playtime throwback? Lego is the poster child here. Those little bricks are injection molded with such insane precision that pieces from the 1950s still snap perfectly with ones made today. We're talking tolerances tighter than a hair's width. But it's not just Lego. Action figures with detailed faces, board game tokens, even those plastic wheels on your kid's toy car, all of it comes from this process. Injection molding lets toy makers dream up intricate designs and crank them out by the millions, keeping costs low and imaginations high. Now, here's where it gets serious. Healthcare. Injection molding is a total game changer in medicine. Picture this: disposable syringes that have to be sterile and perfectly uniform, IV connectors that can't leak a drop, or even parts of artificial joints for hip replacements. These are life-saving tools, and they're made possible because injection molding can use medical-grade plastics like polycarbonate or PEEK that are tough, biocompatible, and safe. The process is so reliable that it's trusted for mass-producing everything from tiny catheter tips to housings for MRI machines. Speed matters too. Hospitals need these parts fast, and injection molding delivers. Then there's the stuff we touch every day, consumer goods. Your phone case? Injection molded for a perfect fit and that grippy texture. The keys on your keyboard? Molded with little ridges so your fingers don't slip. Even those stackable storage bins in your garage. They're tough and lightweight. So, why is injection molding such a big deal? 3 words: speed, scale, and precision. Before this tech came along, making plastic parts was slow and labor-intensive. Think hand carving or casting. Injection molding flips that on its head. Once the mold's made, you can pump out identical parts at lightning speed. Sometimes one every few seconds. That scalability is a game changer. Need 1 million bottle caps? No problem. Need 10,000 car door handles? Done. And because the mold ensures every part is identical, you get consistency that's impossible to match with other methods. Then there's precision. Molds can be machined to capture the tiniest details. Think threads on a screw cap or the texture on a toothbrush handle. That level of accuracy opens up possibilities for complex designs that would have been a nightmare to produce otherwise. Plus, it's efficient. Injection molding uses just the right amount of material. No excess waste like you'd get with cutting or carving. And with modern recycling, leftover plastic can often go right back into the hopper. But here's the kicker: cost. Yeah, making the mold itself can be pricey, sometimes tens of thousands of dollars, but once it's done, the per-part cost drops to pennies. That's why injection molding dominates for mass production. It's the sweet spot of quality, quantity, and affordability. So there you have it. Plastic injection molding, the process that shapes our world one precise part at a time. From the molten plastic racing into the mold to the endless stream of products it creates, it's a perfect blend of science, engineering, and innovation. What's your favorite injection molded thing? Drop it in the comments below, and if you enjoyed this deep dive, hit that like button. Thanks for watching World Made, and we'll see you on the next one.